everyone. Today we're gonna do our last lesson on radicals. That is lesson 5 on radical equations. So in our first 4 lessons of radicals, we dealt a lot with radical expressions. But now in this lesson, we will be doing questions based on radical equations. So let's see what is a radical equation first. A radical equation is an equation with radicals that have variables in the radicand. And I'm pretty sure you know what radicand is because I've talked a lot about this word in my previous videos. So if you have something written like this, that is nth root of x. So x is called the radicand and n is called the index. Okay, and in this video, we will only be solving radical equations that are limited to square roots and I will not be doing any questions that are based on cube roots. Okay, and there are 3 things to remember when solving a radical equation. The first is identify any restrictions on the variable. Second, identify if any roots are extraneous by determining whether the values satisfy the original equation. Third, you need to verify your solutions. Okay, so let's do a few questions based on radical equations. Our first question is, solve the following equations and state any restriction. So whenever we have variable in our radical, we need to find the restriction first. Okay, so here we have square root of x plus 3 plus 4 is equal to 7. In order to see our restriction, you know that our radicand should never be equal to 0. So here our radicand is x plus 3. So x plus 3 should always be greater than equal to 0. We're going to simplify this. So the value of x is greater than equal to negative 3 because I will subtract negative 3 on both sides. So my restriction on x is x greater than equal to negative 3. So if I plug any value of x that is less than negative 3, so this radicand will be negative then, and then square root of negative radicand is not possible to calculate. Okay, so we got our restriction now, and we're going to simplify this question. So we're going to combine these two like terms, 4 and 7. So I'm going to subtract 4 on both sides. Okay, and plus 4 and negative 4 is 0. So you're left with square root of x plus 3 is equal to 7 take away 4 is 3. So I'm looking for the value of x, right? So here I'm gonna square both sides. So whatever I do on one side of the equation, I have to do the same thing on the other side of the equation as well. So I'm gonna square on both sides, squaring both sides. So when I square on both sides, this is what my equation will look like. Okay, and square root cancels out. I'm left with x plus 3 on the left side, and on the right side I'll get 9. 3 square is 9. Let's simplify this. Subtract 3 on both sides. Use your opposite operation method. So x is equal to 9 take away 3 is 6. So our root is 6. So root means the value of your variable. Okay, so we got x value as 6. Now, and x equal to 6 is not extraneous because if you see a restriction says that x should be greater than equal to negative 3 and 6 is greater than equal to negative 3, right? It is greater than negative 3. So our x equal to 6 is not extraneous here. So now we have to verify our solution. To verify our solution, we'll take x equal to 6 and plug that in our original equation. So square root of 6 plus 3 is square root of 9, and square root of 9 we know is 3. So our left side is equal to right side, hence proved. Okay, so x equal to 6 is the root of this equation, or is the solution of this equation. Let's do our part B. So again, if you have a variable in your radicand, you have to first of all find the restriction. So our restriction will be y greater than equal to 0. You cannot plug the value of y less than 0, means y should not be negative here. Okay, so let's simplify this. To simplify this, we're going to combine the like terms, means these constants. We're going to simplify these constants first. So I will add 8 on both sides. Remember to do opposite operation here. So negative 8, positive 8 cancels out. So you'll get square root of 3y divided by 5 is equal to negative 2 plus 8 is positive 6. Okay. So squaring both sides. So we square here, left side, and we'll square our right side too. So square root and square cancels out. You're left with 3y by 5 equal to 36. Let's simplify this for y. We're going to isolate our y. So we're going to multiply by 5 both sides. This 5 and 5 cancels out. And then we'll divide by 3 also, both sides. So we get y equal to, so 36 times 5 divided by 3 is 60. So our root is y equal to 60. And then it is not extraneous, because if you look at our restriction says that y should be greater than equal to 0, and y equal to 60 satisfies our restriction. So we're going to verify our solution now. So to verify, we'll take the value of y equal to 60 and plug it in our original equation. Let's simplify our left side. So 60 times 3 divided by 5 is 36. And square root of 36 is 6. So left side is negative 2. And right side is also negative 2. So left side is equal to right side. So it means that y equal to 60 is a solution. Okay, let's do part D. I'm going to skip part C because part C is quite simple. Okay, I'm going to do part D with you. So here, we have to find our restriction first. So our restriction will be only on this radicand here. Okay, that is square root of 2x plus 3. So we can apply a restriction on the x that is the part of our radicand. So here we should have 2x plus 3. Our radicand should be positive, means it should be greater than or equal to 0. Let's simplify this by subtracting 3 on both sides. So we'll get 2x is greater than or equal to negative 3. So divide by 2. So x is 2 and 2 cancels out. X should be greater than or equal to negative 3 by 2. So our restriction is x should be greater than or equal to negative 3 by 2. And negative 3 by 2 means negative 1.5. So x should be greater than or equal to negative 1.5 here. Okay, so we got our restriction. Let's simplify this question now. To simplify this question, we're gonna isolate our radical first. Okay, to isolate our radical, I'm gonna add square root of 2x plus 3 on both sides. So this is our equation. So I'm gonna add square root of 2x plus 3 on both sides. This cancels out. I'll get 6 plus square root of 2x plus 3. So in these type of questions, we always isolate our radical. Okay, so we still have 6 with our radical. So I'm gonna eliminate the 6 from here by using opposite operation method. So I'm gonna subtract 6 on both sides. So I will get x minus 6 equal to square root of 2x plus 3. So now I'm gonna square on both sides. So squaring on both sides will give us x minus 6 whole square equal to 2x plus 3 whole square. So let's simplify this. So square and square root cancels out. We are left with 2x plus 3. So here there are two ways to solve this question. Either you write x minus 6 twice and FOIL it, or you can just apply your formula a minus b whole square is equal to a square minus 2ab plus b square. Okay, so I'm going to apply the formula here. So this is what I will get. Now I'm going to combine the like terms. So I'm going to subtract 2x on both sides. This cancels out. I'm left with 3 on right side. Now I'm going to subtract 3 on both sides. This is what I will get. So let's combine the like terms here. So minus 12x minus 2x is negative 14x. And positive 36 and negative 3 is positive 33. Let's find the factors of this quadratic equation. X squared minus 14x plus 33 equal to 0. So the factors will be x minus 11 and x minus 3 equal to 0. So here, if the product of two expressions is equal to 0, so here either we get x minus 11 equal to 0 or x minus 3 equal to 0. From here, add 11 on both sides. So our value of x is 11. And on this side, we're going to add 3 both sides. And x is equal to 3. Okay, so we got two roots of x. One is 11 and the other one is 3. Let's look at our restriction to see if we have any extraneous root. So our restriction says that x should be greater than or equal to negative 1.5. And both of our roots are greater than negative 1.5, right? So we don't have any extraneous root here. So let's verify our solution. To verify our solution, we're going to take the value of x equal to 11 first, and then going to plug it into our original equation and then see if left side is equal to right side. Okay, so our original equation is x minus square root of 2x plus 3 equal to 6. This is our original equation. Okay, we need to verify our first root, that is 11. Okay, to do that, we're going to take the value of x equal to 11 and plug it into our original equation. So this is what we will get. Okay, let's simplify our left side. So 2 times 11 is 22. 22 plus 3 is 25. And square root of 25 is 5. 11 take away 5 is 6. So 6 equal to 6. So hence verified. So x equal to 11 is a solution. Now let's see if x equal to 3 is also a solution. Let's verify this if it is true. Again, plug x equal to 3 in our original equation. 3 times 2 is 6. 6 plus 3 is 9. Square root of 9 is 3. Is this true? 0 equal to 6? No, it is not true, right? So left side is not equal to right side. It means that x equal to 3 is not the solution. So this is not the solution. So our only solution is x equal to 11. Okay. Okay, let's do our next question. Next question is write and solve a radical equation to find a positive real number that exceeds its square root by 6. So let's take a positive real number first. Let's take that is x, okay? X is greater than 0, okay? So according to question, our x is equal to square root of x plus 6. Exceeds means you're adding 6 to your the square root of x, okay? Now we're going to isolate our radical. So we're going to bring 6 to the other side by subtracting 6 on both sides. Use opposite operation method. X minus 6 equal to square root of x. Always remember that you have to isolate your radical, okay? Now squaring on both sides. So let's simplify this. X minus 6 square is x square minus 12x plus 36. And square root of x and x square cancels out. We are left with just x. Let's combine the like terms. So x square minus 12x. Let's bring x to the other side. The sign will switch. So positive x becomes negative x here. So let's combine these two like terms here. Negative 12x, negative x is negative 13x plus 36 equal to 0. Let's find the factors of this quadratic equation. The factors are x minus 4 and x minus 9. You can even verify these factors because when you FOIL them, you'll get this equation only x squared minus 13x plus 36. Okay. So here, the product of these two expressions, x minus 4 and x minus 9 is equal to 0. From here, either x minus 4 is equal to 0 or x minus 9 is equal to 0. So here, your value of x equal to 4, or it can be 9 too. Now, we got our solutions. There are two solutions. One is 4, the other one is 9, but we need to verify these two solutions, okay? So we need to see if there is an extraneous root, right? So to verify this, we're going to take the value of x and then plug it in the original equation, okay? So our original equation is this here, x minus x equal to square root of x plus 6. Let's take our x equal to 4 first, and then check if left side is equal to right side. Square root of 4 is 2. This is what we get, right? So on right side, we get 8, and on left side, we have 4, and 4 is not equal to 8. So it means that x equal to 4 is not a solution, okay? It is extraneous root here. Next, x equal to 9. Let's verify our x equal to 9 also. Square root of 9 is 3. Left side is equal to right side here because left side we have 9 and right side also we have 9. So it means that x equal to 9 is the solution of this equation. Okay. Last question. So in this question we have two radicals Okay, so one is square root of 4x plus 5, the other one is negative square root of 2x minus 1. So in this equation, we're going to try to isolate one radical, at least one radical, okay? So here we're going to add square root of 2x minus 1 on both sides. So this is what we will get. We're going to square on both sides. So on left hand side, square and square root cancels out. We are just left with 4x plus 5. And on the right side, either write this twice, 2 plus square root of 2x minus 1 and FOIL it, or just apply your formula, quadratic formula, a plus b whole square is equal to a square plus 2ab plus b square. So after simplifying this expression, you'll get 4 plus 4 square root of 2x minus 1 plus 2x minus 1. Now we're going to combine the like terms and try to isolate our radical sign, okay? So subtract 2x both sides first. This cancels out. And 4 take away 1 is 3. And then gonna bring your 3 to other side, it becomes negative 3. And 5 negative 3 is 2. So this is what we will get. Okay, so I'm gonna square this again because I want to get rid of this radical sign, okay? So again, squaring on both sides. So left side, again, write this twice and FOIL it, or just apply your a plus b whole square formula. So let's simplify this. Let's open the bracket first. 16 times 2 is 32x. And then 16 times negative 1 is negative 16. And now let's combine the like terms by using opposite operation method. So subtract 32x on both sides and add 16 on both sides. So we'll get 4x squared negative 24x, and 16 plus 4 is 20, equal to 0. Let's divide by 4 on both sides. When you divide each and every term by 4, so 4x squared divided by 4 will be equal to x squared, and 24 divided by 4 is 6, plus 5 equal to 0. Let's factor this out. So from here, x minus y, 1 equal to 0, or x minus 5 is equal to 0. So our two solutions are 1 and 5. Okay, let's look at our restrictions too, because we didn't calculate our restrictions in this question earlier. So let's simplify. Before verifying this question, let's find the restrictions. So our restrictions will be 4x plus 5 should be greater than or equal to 0. So let's simplify this for x. So subtract 5 on both sides and then divide by 4. So we'll get 4x greater than equal to negative 5 and divide by 4. X should be greater than equal to negative 5 by 4. Okay. Now we're going to also apply a restriction on our second radical, that is 2x square root of 2x minus 1. So let's say 2x minus 1 should also be greater than or equal to 0. Again, our radical should never be negative here. So add a 1 on both sides. X should be greater than or equal to 1 by 2. So one time we are saying that x is greater than or equal to negative 5 by 4, and the second time we are saying that x should be greater than or equal to 1 by 2. Okay, so from here, let's see what our question says. It says x equal to 1 and x equal to 5. So let's see if it is true. 1 and 5, yes, it satisfy our conditions, right, of our restriction. So but then we also have to verify if these x equal to 1 and x equal to 5 satisfy our original equation, to check if they are if there is any extraneous root or not. Okay, so let's take x equal to 1 first and plug that in our original equation. So this becomes square root of 9 minus square root of 1 equal to 2. Square root of 9 is 3. 3 minus 1 is 2. So our left side is equal to right side. It means that x equal to 1 is a solution. Let's verify our second solution now. So our second solution was x equal to 5. Let's verify this by plugging the value of x equal to 5 in our original equation. Okay. 5 times 4 is 20. 20 plus 5 is 25. Sorry, this is minus. 5 times 2 is 10. 10. Oh, there is a minus here. And then there is negative here. 1. Negative 1 instead of 5. That's our original equation. Negative 1. Okay. So 5 times 2 is 10. 10 take away 1 is 9. Square root of 25 is 5. Square root of 9 is 3. 5 take away 3 is 2. 2 is equal to 2. So it means that x equal to 5 is also a solution of this equation. So that's it for our radicals. We are done with radicals. Okay, thank you.